This is Algebra 1, Unit 9, Lesson 1, Part B, Simplifying Non-Perfect Squares. Okay, so we were talking about the multiplication property of square roots, and that is used to simplify non-perfect squares. Okay, so what we have to be able to do is know what our perfect squares are. You have to be able to recognize at least the first 12. There's actually more than that. There's an infinite number. But if you know the first 12, you should be in good shape. Okay, so let's get the perfect square list. All right, so 1 squared. What is 1 squared? Is 1. All right, then we have 2 squared, which is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. So these are the numbers that you need to know. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Or if you know more than that, there's more, but just working out what you have. If you know those first 12, you should be in pretty good shape. All right, now what do we do with these non-perfect squares? Well, what we have to do to simplify non-perfect squares to what's called simplest radical form. Simplest radical form means there's no more square roots that you could take out. All right, so we want to find the largest perfect square that goes into the radicand. The radicand is the name for the number underneath the radical, underneath the square root symbol. Write the radicand as the product of this perfect square and another number, and then simplify the perfect square and leave the other number under the square root symbol, under the radicand. Okay, now that sounds complicated. It really isn't. All right, here's what we need to do. We want to look at this list right here. We want to find the biggest number that will go into 18. All right, let me work backwards. All right, so the closest 18 we have is 16. Does 16 go into 18? No, it doesn't. Let me go down. Does 9 go into 18? Yes, it does. All right, now remember, we can write 18 under the square root as a product. We could write it as the square root of 9 times the square root of 2. Okay, 9 times 2 is 18, right? Well, we just said 9 is a perfect square. What is the square root of 9? The square root of 9 is 3. And then just leave the other one under the square root. So this is read as 3 times the square root of 2, or 3 radical 2. All right, so the trick is to find the biggest perfect square, one of these numbers, that goes into the radicand. Write it as a product, and then take the perfect square. Okay, let's try another one. The square root of 8. Okay? All right, the biggest one, 9 is too big. 4 goes into 8. I can write 8 as 4 times 2. All right, so the square root of 4 is a perfect square. The square root of 4 is 2. And then the square root of 2 is just the square root of 2. So this is 2 times the square root of 2, or just 2 radical 2. Okay, that is simplest radical form. Okay, 45. The square root of 45. We need to figure out if there's a perfect square that goes into 45. All right, so the biggest number it could be is 36. All right, so 36, does 36 go into 45? No. Does 25? No. Does 16? I don't think so. If I do 45 divided by 16 here, clear that out. 45 divided by 16. Nope, that doesn't go in nice and evenly. However, if I do 9, 45 divided by 9. That is a perfect square. So that comes out to be 9 times 5 is 45. So the square root of 9 is 3 times the square root of 5. Okay, now I can show you some calculator tricks on how to do this. Let's use the square root of 48 as our guinea pig when we do this. Okay, now what I've been doing with the calculator is just working backwards. If you're using Desmos, you'll have to do it that way. I'll demonstrate it again with 45. All right, so, or 48, excuse me. All right, so what we want to do is we want to break down 48 into the biggest perfect square that we have. Now there's a couple perfect squares that go into 48. 4 goes into 48. 16 does as well. So how do we know which one to use? Well, we want to work backwards from the biggest one that it could work. All right, so if we go back here, 49 is too big. 36 is the one below it, but 36 doesn't go into 48. 25 doesn't. Let's see if 16 does. 48 divided by 16 is 3. Yeah, that does. Okay, so that's going to be 16 times 3. All right, now that will simplify. The square root of 16 is 4 times the square root of 3. Okay, so that is simplest radical form. Now, what if you said, oh, well, 4 is a perfect square. 4 goes into 48. 4 times 12 is 48. And that simplifies to give me 2 times the square root of 12. Okay, is this simplest radical form? No, it's not, because 12 will break down again into 4 times 3. We can take another perfect square out of there. So if we do that, that's going to give me the square root of 4 is 2, so this will be 2 times the square root of 3, which is 4 times the square root of 3, and I got the same answer. So that's why we want to take the largest perfect square that we can to go into the radicand. All right, now I have a cool calculator trick that you actually already know on how to do this. If we go to y equals in the calculator, just like we were doing for factoring, if you do the factor, 48 divided by x, go to your table. All right, what you want to do is look in the blue column starting at 0. Let me put it to the top here so we can get it there. All right, you want to look at the blue column here, the y1 column. Find the first perfect square that you see starting from 0. What's the first perfect square that you see in the blue column? Well, it would be 16. So I know this is going to be 16 times 3. That's where we got that from. Okay, now notice here, if you keep going, you will eventually get to 4 down here. 4 will work, but it's not the one closest to 0. So the trick on the calculator is to do y equals, just like we do 48 or whatever radicand you're doing, divided by x. Find the one closest to 0 that's a perfect square. 16 is a perfect square, that's closest to 0. Okay, if you're doing this on Desmos, you have to use, you have to just do the division. All right, so if I do Desmos, I have to do working backwards from my perfect square, my list of perfect squares. Where's my list? There's my list of perfect squares. All right, 48, I'd have to do each one divided by, 48 divided by each one of those. So I'd have to do, put this up here, 48 divided by 36. Does that work? No. Okay, then I'd have to do 48 divided by 25. Does that work? Nope. All right, then I'd have to do 48 divided by 16. If I work backwards from the biggest, that is 3, so that will give me the one that I need. So you have to be able to work however you have it from each of the values to do that in simplest radical form. Okay, let's try a few more. Okay, the negative square root of 75. All right, the negative I'm not worried about, that's out front. So the negative just stays out front, and I want to break this down into 2 perfect squares. What perfect square goes into 75? All right, well, here's my list. Whoops, where's my list? Here's my list of perfect squares. Oops, went too far. All right, so I want to start here. Does 64 go into 25 or 75? No. 49, 36. How about 25? 25 does. So this would work out to be 25 times 3 is 75. All right, what's the square root of 25? It's 5. Now, since this is negative out here, we just make the answer negative when we're done. So that's going to be negative 5 times the square root of 3. Okay, now 72 might be one that you might want to use in the calculator. All right, so 72 I want to break down. Let me grab my calculator. Y equals 72 divided by x. Look at your table. All right, starting in the blue column, what's the first perfect square that you see? 36 is a perfect square. 36 times 2 is 72, so I'm going to use that. 36 times 2. So that's going to be square root of 36 is 6 times the square root of 2. Be very careful. Make sure that this is a square root when you do that. Okay? The negative square root of 500. All right? The negative stays out front, and we'll worry about that. So we're going to have a negative answer when we're done. All right? So if I go to my calculator, I'm just going to do the 500 divided by x. And then if I go to my table, First perfect square that you see is 100 in the blue column. So it's 100 times 5. All right, so it's 100 times 5. The square root of 100 is 10. So this is actually going to be negative 10 times the square root of 5. Okay, 2 times the square root of 98. All right, the 2 I'm not worried about. We multiply that out later. All right, so I need to figure out something with 98. All right, let's do this one on Desmos so that we can practice. All right, so if I look at my list of perfect squares, I'm going to use 98. What is the biggest one in my list? All right, let me flip back here for a second. 98 would fall between 81 and 100, so let's try 81 and work backwards. So divided by 81. Does that work? Nope. All right, let's try the next one. 49 would be the next, 9 squared, 8 squared would be 64. Does this work? Whoops. 98 divided by 64, sorry about that. 98 divided by 64. Does that work? Nope. All right, so that's 9, 8, 7 squared, 98 divided by 49. The next one in my list is 2. 49 times 2 is 64, so that one works, or is 98, sorry. 49 times 2. All right, now square root of 49 is 7. What do we do with the 2 out front here? Well, we multiply them together, because this is read as 2 times the square root of 98. So it's 2 times 7 times the square root of 2. 2 times 7 is 14 times the square root of 2. Okay. All right. What about exponents? X to the third power. All right, what kind of exponents are perfect squares? Even exponents. So I have to be able to write x to the third using an even exponent. Well, how can I write that? What's the biggest even exponent that would go in x to the third? Well, wouldn't it be x squared? And x squared times what gives you x to the third? It would be x. So you want the biggest even exponent you can that goes in x to the third. What's the square root of x squared? It's just going to be x times the square root of x. All right. Square root of x to the seventh. What's the biggest even exponent that you could write as a product of x to the seventh? I'll give you a hint. It's always going to be one less. So this is going to be x to the sixth. All right, now what is the square root of x to the sixth? What do we do with the exponent? We divide the exponent by 2. So the square root of x to the sixth is going to be x to the third, because x to the third times x to the third is x to the sixth. So this is going to be x to the third times the square root of x. Okay. Then we have x squared y to the fifth. All right, now don't let the extra variable throw you. We're just going to do that. Is x squared a perfect square? Yes, it is. So we're going to leave x squared under its own radical. All right, now y to the fifth we want to break down. What's the biggest even exponent that goes into y to the fifth? Well, it would be y to the fourth. That would go here times y. All right, so this is a perfect square. This is a perfect square. What's the square root of x squared? It's just going to be x. What's the square root of y to the fourth? Divide the exponent by 2 is going to be y squared. And then this just stays to be y. So your answer is xy squared times the square root of y. All right, for the last one, let's just combine the numbers and the variables. So the -3 we're not worried about right now. We'll worry about that later. All right, now we want to break down 24. What perfect square goes into 24? Here's my list. All right, 24 to 16? No. Does 9? No. Oh, 4 does. So this is going to be 4 times 6 is 24. All right, now what's the biggest even exponent that goes into x to the 9th? Well, it would be x to the 8th times x, because multiplied together, that'll give me x to the 9th. All right, so that means this is a perfect square, and this is a perfect square. Let me put them in order. So we have the -3. The square root of 4 is 2, and the square root of x to the 8th, divide the exponent by 2, will be x to the 4th, and then times the square root of 6 times the square root of x, because these aren't perfect squares. Multiply these together, it gives me -6 x to the 4th, and then we can multiply these together. 6 times x is 6x. And there we got it. All right, so the trick to doing this is take the biggest perfect square that you can and write it as a product of another number, and then take it out. All right, so we have some practice for this. Please do the homework now.